Hello everyone. So this is the first lecture of the part 3. In the part 3, we are going to study the circuit. First chapter is the resistors and the inductors. Second chapter is the direct current circuit. Third chapter is the alternating current circuit. First chapter is the resistors and inductors. First topic is the resistors. Second topic is the resistors in series and parallel. Third topic is power. Fourth topic is the inductors. Last topic is the mutual inductance. First topic is the resistors. Current density is proportional to an electric field in metals. Was discovered by Ohm in 1826. So using the equations, current density I is proportional to the electric field of E. If you take a ratio of the magnitude of E over I, this ratio becomes a constant quantity. So we call it resistivities of law. Unit of law is volt times meter over amperes. For example, in the case of the copper, is 1.72 times 10 to minus 8 volt meter per amperes because copper is a metal. The charge is easily moved inside of coppers. But in the case of the glass, charge is difficult to move. So resistivity of glass we expect is really high. So number is 10 to 10th to the 10 to 14th volt meter per amperes. So as we expected, the resistivity of glass is much larger than the resistivity of copper. So if we know the resistivities, we could estimate the mean collision time of electrons. So current density I is expressed charge Q times number density N times drift velocity of electrons. And the drift velocity V sub D is expressed Q tau E over M. And tau is the mean collision times. So if you use mean collision times, this quantity is expressed N Q squared tau over M times E. Then if you use the resistivities of law, resistivity is expressed E over I. Then you can substitute this here. It becomes M over N Q squared times tau. So from these equations, you can find out the mean collision time of electrons can be expressed M over N Q squared times rho. So for example, for copper, rho 1.72 times 10 to minus 8 volt meter per amperes. Number density of electrons is expressed 9 times 10 to 28 per cubic meters. And the charge Q is electrons 1.6 times 10 to minus 19 coulombs. So you can substitute all the numbers into this equation to find out the mean collision time of the electrons. It becomes 2 times 10 to minus 14 seconds. So mean collision time of electrons with ions, it becomes really short, 10 to minus 14 seconds. So once we know the resistivities of materials, we could estimate mean collision time of electrons. Then I'd like to explain the resistance. So we consider the metals of wires. Length of the wire is L. And the electric field is generated inside of the metals from the higher potential to the lower potential. And the potential difference between the two ends becomes a V. The electric field is expressed E equal rho times I. I is current densities. And the areas of the cross sections of wires. Current is I is equal to current density times the area of the wire A. And the voltage difference can be expressed as V equal electric field times length of wires, E times L. Then you can substitute this E is here. Then it becomes rho I L. Then for the I, you can substitute here. Then it becomes rho L over A times I. So voltage difference between the two ends of the wire is expressed as V equal rho L over A times current I. This rho L over A, we call it resistance. Resistance is R is expressed as V over I is equal to the rho L over A. So resistance becomes larger with the length and smaller with the areas of the wires. And the unit of the resistance is expressed ohm. In the circuit, we use the resistors. This is a symbol. Resistor has a resistance of the R. The resistors have a 4 color code. In this example, you can find a 4 color code. The most left hand side, you can find that green. Look at the table of the color code for resistors. Greens. It's going to be 5. So this means first color show this number of 5. And the second color, you can find the violet. Also, again, you can find the number 7. So 5, 7. And the third color is a red. Third color is a value as multipliers. So you can find the red. It's 10 to 2. So this is red. So this is violet. This is the green. 5. So using the 3 color code, you can find the magnitude of the resistance of this resistor is expressed 5.7 kilo ohms. And the fourth color is expressed the precisions of these numbers. If you find the silver, precision is plus minus 10%. If you find the gold color code, it becomes a plus minus 5%. Okay, in the first lectures, I explained the resistivity and the resistance. Okay, this is the end of the first session.